Hello, good morning, and happy Thursday. Well, it may not be morning for you anymore, but happy Thursday anyway. And I'm actually recording this video on the day of because I wanted to wait and get your responses for the 11.1 practice. You have a quiz tomorrow, so I want to make sure that I go through a lot of the commonly missed questions so that you can feel confident and move forward and take your quiz tomorrow. After this video, you need to fill out the little form on Google. There's a link in the lesson plans. And it's just basically, yes, I watched this video, made corrections, whatever. So it shouldn't take you very long after you finish this video to wrap things up for today. And then it'll take you a little bit longer for the quiz tomorrow, obviously. So you want to plan ahead for that. Okay, so let's talk about some of the non-math questions first. Most people did really well on the non-math part. One thing I do want to point out is where it asks you to list 3 types of potential energy. I was really surprised that some of y'all obviously Googled this because you gave me some rando answers that I didn't go over in the teaching and they weren't in this chapter in the book. So I had to give you credit because technically if you're going to classify it as potential energy or kinetic energy, it was potential energy, but things like thermal energy and magnetic energy, we usually treat separately. So please try to stay away from Google for something that I've taught clearly and also that it's clearly found in the chapter. So stop Googling your answers. Sorry, just had to say that. And that does not apply to everybody. It was just a couple of people. But anyway, you know who you are, by the way. And moving on to the next one, most people got the thing about describing a situation where your reference level would not be the ground. You had to be pretty specific about this. So you can't just say an eraser falling off a table or something like that, because that implies that the ground is still the reference level. But a good one to say would be like a vase falling from a shelf onto a table. Or you could say somebody climbing from one rung of a ladder down to another rung of a ladder. And so you need 2 levels that you're referencing, and they're not the ground. None of those are the ground. So just be sure to be specific about a question like that. And again, you have a quiz on this tomorrow. And I think all of the rest of the non-math things were pretty okay. So let's shift over to me. Other than a couple of significant digit issues, the last 3 math problems were the ones that I need to go over. And just to show you behind the scenes, this is what I do. I look at your stuff on the computer and I'm able to elongate stuff clearly here. You can see I've color coded and stuff like that, but I'm able to pull it out on the computer and then I'll highlight the wrong answers, and then I can even color code for a math problem whether it's wrong or a significant digit issue and things like that. So for your 11.1 practice, I'm going to be putting those grades in the grade book later today, but blanks were -8, wrongs were -4, and significant digit issues were -1. So you'll be able to see your grade in the grade book. And then all the ones that I'm going over are ones that people got wrong, other than a significant digit issue here or there, but that's not a big deal. But the 3 that I'm going over are nobody missed any of the other ones, is what I'm trying to say. So let's go ahead, and I don't know if it numbered yours for you, but for me, on the printout thing, it was number 13 about Jennifer. And there were a couple typos in this. Did you notice how big Jennifer's mass was? Clearly, I forgot my decimal point, and I also forgot my dash in meters per second. So, but you should have been able to do the problem still. And so this was a kinetic energy problem. This is actually one that we were talking about in the last chapter. So I'm going to be really quick with this one. Her mass was obviously way too big, but just go with it. If you ever are given something like that on a quiz or test, just go with it. And the professor or teacher will have to adjust later. But it says her velocity, wants to know the kinetic energy. Again, this is one that we kind of already had, but we're dealing more with kinetic energy in this chapter as well. But the formula is 1/2 mv squared. And then when you put it in, remember to use 0.5 instead of the 1/2. It's so much easier. And then that huge, big, unreasonable mass. And then I bet if you missed this problem, you forgot to square it. So look back at your work. You should still have your work. Again, this is the one about Jennifer. And the numbers should be matching up. And then here's what you get before rounding, and then we just have 2 significant digits. And again, I bet if you missed this one, you just forgot to square the velocity. So there's that. I think we're good to move on. I want to spend a little bit more time on the final two because those are a little bit more complicated. So the next one I want to go over on my printout, it was number 17. Like, I don't even know if you can print yours out or when it shows you your thing, if it tells you a number, but it's the one about the 17 kilogram cart. And so you've got a 17 kilogram cart moving with a velocity of 1.88 meters per second on a level floor with a constant force of 28.75 newtons, and that slows down the cart to only 0.39 meters per second. And I want to know how far the cart moved while the force acted. And I even gave you a hint. And so we're going to work this through together on here, but the things that you know are the mass of the cart, which is 17 kilograms. Sorry, it's like backwards for me, so that's why I have to turn it around to actually see what it says. And then the initial speed of the cart or velocity of the cart is 1.88 meters per second. Then this force is going to slow it down to only 0.39 meters per second. And I want to know how far the cart moved. And so this top one was a hint that I gave you. And remember, this is from a previous chapter, so you're having to draw on that knowledge that you should already know. But work equals force times distance. And so what I want to do is I want to take force times distance and plug it in for the work. And so when you do that, and you can follow along and update your problems. Like if you missed this one, you should be updating it with us right now, along with me. And so it's going to look like this. FD equals delta KE. Okay, so let's think about what we have and don't have. Do we have the force? Yes. We're being asked to find distance, so we know we're going to need to solve for D. Delta KE. Do we have the components that we need to find kinetic energy? Yes, because remember kinetic energy, that's KE equals 1/2 mv squared. And then I'm going to write this a little bit neater. There we go. So we have the mass, and it's in kilograms like we need, so yay for that. And then we have both velocities. And so when we change kinetic energies, the mass is not changing, that 1/2 is not changing. The only thing that's changing is going to be the velocities. Okay, so we're going to end up writing it like this. So FD equals 1/2. I'm going to factor out the 1/2 and the m because those aren't changing. And the only thing that's changing would be the velocities. And it gets a little bit weird. Okay, but just bear with me. Yeah. So take a moment. And remember, what I did is we already had substituted the FD for the work. And then for delta KE, regular kinetic energy, if you're just dealing with one velocity, is 1/2 mv squared. But since we're doing the change in velocity, remember it's the second one minus the first one. And we don't have to factor that out. Like you could do 1/2 mv2 squared minus 1/2 mv1 squared. That's a lot of extra work. So just do it like that. Will be good. And then I'm going to go ahead and take a moment to plug in these numbers. And so sorry if you're like bored, but I got to plug these numbers in really quick. So you might be doing the same thing. You know, I think I'm going to start on a new, I'm running out of room on my dry erase board. These are rather small. And I also want to get a darker marker. Okay, so when we're gonna plug in for force, and so that's gonna be the 28.75 newtons. Oh wait, you know what? Before I do that, I'm jumping ahead. I didn't even solve for distance stuff. Okay, so before I start plugging in stuff, I need to get rid of the force, and so I'm gonna divide both sides by the force. I'm so glad I realized that before I started plugging everything in, and this is the formula I need. Let's do that now. So let's try that. Okay, so we're going to do 0.5 instead of our half. And then we're going to use the mass, which is 17 kilograms. And then you're going to have to square each velocity. I'm not going to put in the units, meters per second for each one because that just clogs it up even more, and I most certainly will run out of room. And then divided by the force. Okay, so I'm going to leave that up there for a minute. Okay, so there's my 1/2. There's my m. That's v2 squared minus v1 squared. And then the force, you're dividing by that on the bottom. And so if I were doing this problem, I would do this squared minus that squared times that divided by that. Like, watch your order of operations. Sorry, I'm trying to hold this where there's not a big glare on it. But if I'm going to take this away, but if you need to see this more, just pause the video. And then when you work it all out before you round, okay, you really get negative 0.96637. But I didn't count off if you didn't do the negative part. Like, I'm trying to make this as easy as possible. And so I didn't emphasize the direction as much. Okay, so I was happy either way. Like, technically, you're more right if you say negative because it's showing that, it was slowing down and all that. So that's fine. But anyway, when you round, you got to do it for 2 significant digits. The 0.5 and the 1 from the 1/2 does not count for significant digits. So you really should end up with 0.97 meters, like that. And then again, if you need more time, pause this video. All right, we've got one more, which is number 15, or the last one. Like I said, I don't even know if yours is like numbering it or whatever, but it's calculate the velocity of a 52-gram ball thrown through the air if its kinetic energy at that moment is 4.10 joules. So this is just a strictly kinetic energy problem. It doesn't deal with work or anything like that. And I just wrote down what we're given so we can work through it together. Okay, but you're supposed to calculate the velocity. It gives you the mass. Do you see a red flag here? Yes, you do. Okay, it's in grams, not kilograms. And so when we do this, we've got to change it to kilograms. I shouldn't have written that formula. Hang on. Got an eraser. I stole an eraser from my classroom because I'm at home. But when you change grams to kilograms, just move the decimal place over 3 times. There you go. Oh, kilograms. There we go. Ta-da. Okay, so hopefully you caught that. And then it gives you the kinetic energy. And so I'll go ahead and just rewrite the formula down here. Ke equals 1/2 mv squared. And so we need to solve for v. And so don't worry about the fact that it's squared at first. Just get it isolated, and then we'll worry about getting it unsquared. And so to get v by itself, we need to get rid of the 1/2. And so how do we get rid of a 1/2? Let me change marker colors. Go ahead and say it. Okay, how do we get rid of that 1/2? Okay, we're gonna multiply by 2. So we're gonna multiply by 2 here and here. So that's gonna get rid of the 1/2. And then how do we get rid of that m? We're gonna divide. So let me change pens again, markers. So we're gonna divide both sides by m. Okay, and then the m goes away. And so I'm gonna clean this up. We end up with v equals, this black marker is sad. Hang on, it's not even working well enough to use. Okay, so again, we're going to end up with v squared is equal to 2ke over m. Okay, so clearly we're not done yet because the v is still squared. We need to get it unsquared. So what's the opposite of squaring something? You take the square root. So take the square root of both of these. So v is equal to the square root of 2ke over m. And I'm going to do that problem on a separate thing. So we're going to do the square root of 2 times 4.10 joules divided by, don't forget to use the kilogram version. Very important. 0.052 kilograms. All right. Okay, and then before you round, you get 12.5576. meters per second. And then this 2 came from when you multiply it by 2 because of that 1/2. That is not part of your significant digit stuff. I think most of y'all are very aware of that. So dealing with the other things, like this only has 2 significant digits. And so we're going to have to go with 2 significant digits for our final answer. So that rounds to 13 meters per second. So hopefully you followed along and continue submitting your comments, prayer requests, things like that. I know Neil wants to know why I hate bowling, and I'll just tell you really fast. I'm terrible at it. I spend the whole time switching around balls, trying to figure out which one is the best one, and I'll get a strike every now and then. I'll have no idea why or what I did right, and I won't be able to replicate it, and it's just extremely frustrating. And I only do it like once every 3 years, so I have no chance it being good. So it's just like a fail for me from the get-go. So that's why I hate bowling. But hopefully you were able to clear up your math stuff. Please email me at sdixon@evajax.com if you still have issues, if you're still wanting to get clarification on something. And I hope you all do wonderful on your quiz tomorrow. And we're just moving ahead, doing the best we can in our self-isolation, voluntary isolation lives right now. And just keep pressing forward and doing your very best.